So we're doing triangle congruency. These are the main four ideas that two triangles can be similar. They can be congruent. They can be congruent by side, side, side. Those dashes over there, they represent that those sides are congruent. 2 dashes, these two sides are congruent. 3, these two sides are congruent. If you're going to prove congruency by side angle side, the angle must be between those two sides. And a good way for you to remember is it has to follow the same order as the proof that you're trying to come up with. So side, angle, side. Or you can go the other way around too. Side, angle, side. You also have angle, side, angle. So the side needs to be between those two congruent angles. Angle, side, angle. Or angle, side, angle. Angle, angle, side. So you have those two angles and then a non-included side. Those two angles and a non-included side. These two angles are congruent. These two angles are congruent. These two sides are congruent. So how do you write the congruency statement? Has to be in the same order. I like to do 1, 2, and 3. So just to keep that organized in my thoughts so I don't have to think too hard next time I'm doing it. But if you look at the first example right here, we have 1 dash on both sides right there. You have 2 dashes right there on both sides. And you're like, how can I prove that these two triangles are congruent by side, side, side? Well, these two triangles are sharing this one side. So that means by definition that this side is also congruent. So I'm going to write that these two sides are congruent. These two sides are congruent. These two sides are congruent, even though it's only one side that they share. But if you were to split those two triangles, they would be congruent. So, congruency statement. Triangle FIH is congruent to triangle. I'm going to go in the same order. 1, 2, 3. Congruent to triangle FGH. The way you read this, angle F is congruent right there. Angle I and angle J are congruent. And angle H right there. The next one we have side, angle, side. Side, angle, side. The angle must be between those two congruent sides. This side is congruent to this side. This angle is congruent to this angle. This side is congruent to this side. Congruency statement will be triangle HGE. Now I'm going to go the same order on the other triangle. So I did 1, angle, 2. I'm going to do the same thing. 1 dash, the angle, and then 2 dashes. So I, J, K. Angle, side, angle. Angle, side, angle. Sorry. This side right here was given that is congruent to this side. So angle, side, angle. So triangle V is X is congruent to triangle. I'm going to go in the same order. Angle, side, angle. V, T, R. These two angles are congruent. These two angles are congruent. These two angles are congruent. And it also works for the line segment. These two line segments are congruent. VS and VT are congruent. And then you can also read that the other line segment, this line segment SX is congruent to line segment TR. That's how you read the triangle congruency right there. All right, last one. Angle, angle, side. It has to be in order. So two angles and a non-included side. But I only have one angle and one side. One angle and one side. Well, by definition, I know these two angles right here, they're vertical angles. And by definition, vertical angles are always congruent. Vertical angles are congruent. I'm not assuming anything. This is a definition. So based on that, I can conclude that angle, angle, side, angle, angle, side. Now I can conclude that these two triangles are congruent by angle, angle, side. Let's write the congruency statement. Triangle, angle, angle, side. So angle C, angle B, and A, congruent to triangle, angle, angle, side.